Alright, now that you've worked on that second self-quiz and tried to organize all the knowledge there, let's ask, which of the models seem to be settling down to something as time gets bigger and bigger? And can we say why some models do and why some models don't? And can we say what they might settle down to? Is there any way to do that from looking at the model and the numbers? So in your checkup quiz, you probably have those all in one place. I've got it here. I didn't fill these in. You filled those in. But let's say the compound interest population growth, that one seems to be settles. Does that settle down? No, it just keeps growing. Radioactive decay, that one does settle down towards 0. And the single dose of medicine. The loan repayment, that started off getting paid off slowly and then faster and faster, so that didn't settle down. Saving a little each year also didn't settle down. The savings account just grew more and more, or if we started with too big a negative number, it just grew more and more negative. Repeated dosing did settle down. Maybe near 600-ish, I don't remember, maybe it was 500-ish. We never really spotted it exactly. Newton's law of heating and cooling did settle down to the ambient temperature, so that was interesting. And then limited population growth, that one got really complicated. Let's go take a look at that. Here, if you started with 10, it ended up settling down to the carrying capacity. If you started with more than the carrying capacity, it ended up settling down. But if you started with negative animals, it did not settle down. So that's something to think about. So it settled down to the carrying capacity. If you started with a positive initial population. If you started with negative, ran away to negative infinity. So what can we say about these systems and stuff that might help explain all this and predict what it might settle down to? Well, is there any graphs we haven't looked at? We often like looking at graphs. We've looked at a lot of graphs, but what haven't we used? Think about it. 3, 2, 1. Those delta graphs, we've had those there all along, but we never really looked at them. So let's go look at the delta graphs. So way back here for compound interest, this was our graph with time on the x-axis and amount on the y-axis. Then there was this graph that we never really looked at after we made it, with amount on the x-axis and the change amount on the y-axis. This is why I was very careful to label the graphs, because we've got multiple graphs flying around here. We have to have our axes labeled to figure it out. So how is time represented on this graph? Well, we started out with nearly 0 account balance in the grand scheme of things, and nearly 0 delta. So we started out down here, and then by the end of the 500 years of interest or something, we ended up with a really large account balance and a really large delta. So we started out here, and we ended up out here. So time is actually represented on this graph as kind of movement of the points along one direction or another. So that's our delta graph for compound interest. Population growth was pretty much the same. Here's our delta graph for radioactive decay. Single dose was pretty much the same. There you can see more easily. We started out with a large amount of medicine and a large negative delta value, and then we had a smaller amount of medicine and a slightly smaller delta value, and we proceeded towards 0. Here's the delta graph for mortgage. Saving a little. There's our delta graph. Repeat dosing. There's our delta graph. That looks a little different. So anyway, I've collected all of these here, and I labeled them. So a good activity is to sort these into, like over here, these aren't sorted right now. Over here, put the ones that maybe did settle down, where the original trajectory did settle down, and over here, put the ones that didn't settle down. All right, so this will be in the spreadsheet I'm going to email out, so you can go do that now, or you can do it on paper. And pause the video in 3, 2, 1. So hopefully you've organized the graphs into systems that did settle down, systems that didn't. I've done my own here. I might have accidentally switched did and didn't from what I said in the video. I'm sorry about that if I did. So what I have is the ones that did settle down: radioactive decay, repeated dosing, and heating or cooling. What didn't settle down was compound interest and population growth, the mortgage or student loan, and the saving a little each year. And then the limited population growth was an interesting story, right? Because did that settle down or not? Well, it settled down if you started out positive or even above the carrying capacity, but if you started out negative, it didn't settle down. And when it started out positive, it didn't settle down towards 0, it settled down toward the carrying capacity. So what can we say about whether limited population growth settles down or not? Well, sometimes it does and sometimes it doesn't, or it depends on where you start. So we'll let you think about that. Let's come back here. What patterns do you see in the shape of those that where the system did settle down versus didn't? Think about that. And what patterns do you see here that might tell you something about where the system settles down? This one settled down, radioactive decay settled down to 0, repeated dosing settled down to something 500-ish. The heating cooling settled down to the ambient temperature, which was 350. These ones didn't settle down, so we might think, is there something like settling down that kind of goes on there? And limited population growth settled down to the carrying capacity, which was 100, but if I started at 0 or near 0, then it ran away. All right, so here's what to really think about. Think about the x-intercept. Think about the slope of the graph near the x-intercept. Most of them had a constant slope, but the one had the limited population growth was a parabola, so it had different slopes in different places. Think about what settling down means. Does that mean that there's no change once it's settled down? And no change is another way of saying the change is 0. So here's our wrap-up, and this is the last of the 3 self-quizzes in that file you downloaded. So we'll have the delta formula here and the graph just like before, the graph versus time, but then a graph of the delta formula of the delta plot. And then was it stable or not? Like, did it settle down or not? So this is a way of organizing all of our knowledge onto one sheet. Alright, so go organize all your knowledge onto one sheet, and then we'll do something completely different in the next video.